Welcome students. I welcome you all in this online class. Today we'll be discussing the topic photochemistry of carbonyl compounds. We have already discussed the general part and an important reaction, that is photoreduction reaction. Today we'll be discussing one more important reaction, that is the Paterno buchi reaction. This is a photoaddition reaction, and this is also a very important photochemical reaction. So let us study this reaction in detail. Carbonyl compounds yield oxytenes on irradiation in the presence of olefins. So here you can see the reaction: carbonyl compound plus olefin. In presence of light, oxytenes are formed. This photocycloaddition is usually referred to as the Paterno buchi reaction. Since the addition is usually performed by irradiation with the light of wavelength absorbed only by the carbonyl group, it involves the excited state of the carbonyl compound rather than that of the olefin. The light energy required for the N-pi star transition initiates the reaction in simple carbonyl compounds, while for some conjugated ketones it is difficult to distinguish between N-pi star and pi-pi star transitions. The available evidence favors participation by both the excited states in the later case. It has been established that carbonyl compounds undergoing Paterno buchi reaction can also be photoreduced upon irradiation in the presence of protic solvents such as isopropyl alcohol, leading to the formation of pinacols. We have discussed this reaction in detail in our previous video lecture, so you can go through it. The inability of a carbonyl compound to undergo photocycloaddition is always coupled with a similar inertness toward photoreduction. These facts tell us that the two reactions are initiated by the same type of excited state, and that this excited state is a triplet species, has been shown in the case of photoreduction processes. And on that basis, the mechanism of this reaction, that is Paterno buchi reaction, can be written as follows, as you can see in this video slide. So here you can see benzophenone in ground state. On irradiation, singlet excited state of benzophenone is formed. This state undergoes intersystem crossing, that is ISC, and triplet excited state of benzophenone is formed. Now this triplet excited state of benzophenone reacts with isobutene to form oxetane, and the product formed here is 90%. Since the olefin used in the above reaction is unsymmetrical, theoretically, two products should arise from this cycloaddition. The other product is obtained only in 10% yield. Preferential formation of the major product indicates intermediacy of biradical, and logically the addition takes place to yield preferentially the most stable biradical intermediate first. So you can see here, the whole reaction occurs basically in two steps. First step is the excited carbonyl compound in triplet state add through its oxygen atom to the olefin and form biradical intermediates, that is first and second. Now first biradical is of 3 degree and is more stable, and the second biradical is 1 degree and is less stable, and so the product formed from the biradical first one is A, and that is 90%, while the product formed from the less stable biradical intermediate second is only 10%. You can see this here in this equation visible on the slide. And then in the second step, spin inversion takes place, second bond is formed, and cyclization leads to oxetane formation. So this is the complete mechanism of reaction of benzophenone with isobutene forming oxetane. And you can see two products, that is A product is 90% and B product is 10%. Moreover, irradiation of benzophenone with either cis or trans to butane yields the same mixture of both isomeric oxetanes. So had it been a concerted reaction in which both the bonds were formed simultaneously, different products would have been formed in each case. So the above result confirms intermediacy of a biradical in which the stereochemistry is lost. A serious drawback of the Paterno-Buchi reaction is the competing energy transfer process from the excited ketone to the olefin in cases where the triplet energy of the former exceeds that of the latter. Irradiation of acetone with norbornene, for instance, yields dimer of norbornene rather than oxetanes. So this reaction is acetone sensitized photodimerization of norbornene. You can see the equation written here and understand it easily. So here, as you can see, first is the acetone in the ground state, and the triplet energy of acetone is 78 kilocalorie per mole. On irradiation, singlet excited state of acetone is formed. Now this singlet excited state undergoes intersystem crossing ISC to form triplet excited state of acetone. Then in the next step, you can see in the equation part, so this triplet excitation state of acetone reacts with norbornene and the energy is transferred from acetone to norbornene, and acetone comes in ground state and triplet excited state of norbornene is formed. This triplet excited state of norbornene forms dimer. So this is acetone sensitized photodimerization of norbornene. However, when a ketone having less triplet energy is used, we get the oxytocin of norbornene. For example, benzophenone. The triplet energy of benzophenone is 69 kilocalorie per mole. So if benzophenone is used, then we get the oxytocin of norbornene. So that's all. So this is a very important reaction. It's asked in examination many times. So study this in detail. Thank you so much. That's all for today. In our next video lecture, we'll be discussing some more important reactions of photochemistry of carbonyl compounds. And these are Norrish type first reaction and Norrish type second reaction. So till then, thank you so much.